Good afternoon. We are from Group 8. My name is Raisa Anindra. I am with Faiz, Iza, and also Naila. We'll be presenting about our Bitcoin daily price dataset, machine learning methods, and comparison.
Okay, so in this project, we want to predict Bitcoin's closing price using past data. The Bitcoin prices go up and down a lot, so it's hard for investors to make a decisions. That's why we need a model to help us predict prices. We use data like open price, high volume, low, and daily change to do this, but the data is not always clean. There is noise and missing values. We clean the data and use models like linear regression, random forest, and k-nearest neighbors. Then we tested them using MAE, RMSE, and cubic scores. And in the end, our model can give good price predictions and help investor make smarter decision. The next one. For the dataset information, the dataset has daily Bitcoin data with features like open, high, low, closed, volume, and change percent. We clean the data by changing text to numbers, fixing dates, and revealing missing values. The target we want to predict is the closing price, and this data is useful because it helps us see patterns in price and volume, and it also gives a good base for training models and predict future prices.
Okay, so going over the EDA or the exploratory data analysis. For this one, we're going to be explaining the df.describe. So the df.describe, it's basically a summary of the dataset, which shows the dataset span from 2010 to 2024, which with 4,985 entries. So from this dataset, we can see that it has the date, price, open, high, low, volume, and also the change in percentage. And also the df.describe shows the count, the mean, the min, the 25%, 50 percentile, 75th percentile, and also the max and standard deviation. So it shows that the average Bitcoin price tend to be around $10,000, with the maximum price reaching almost $70,000 and a minimum of just 0.1 cent. So the data spans from July 18th to 2010, July 18th, 2010 to March 10, 2024, which captures a significant growth and volatility of the Bitcoin over time. And also the volume traded has an average of approximately 12 million, peaking at over 4.47 billion. So next, for the EDA, we have the data visualization for the price trends. On the top left, we can see that it's basically the line of code which was used to create the line plot, which includes the data and the open price. And also for the right one, the image on the right, the graph, it is basically the data that are processed from the following code. So when analyzing the following data set or the graph, the line plot, it illustrates the trends of Bitcoin opening and closing prices from 2010 to early 2024, which both metrics closely track each other, indicating minimal intraday price gaps. And we can see that there is an uptrend on the graph, which it always goes up and peaks at 2022, and it went down again and it goes up again. So basically on 2017 and 2021, it marked major bull runs, which means the graph goes up, and post 2022, post 2020, it shows high volatility prices in 2024. It approaches all-time highs, opening and closing prices are closely aligned. So still at the data visualization part for the EDA. Next, we have the volume of trade. On the left, we have the code for the data on the right, the graphs. When analyzing the following graph, it shows the volume of trades for Bitcoin for most of the period where the trading volume remains relatively low and stable. However, there is an extremely sharp spike at around 2022, where the volume briefly jumps to nearly 4.5 billion that, as I mentioned earlier, from the df.describe. So, in summary, um, low activity pre-2021, Bitcoin trading volume was minimal during its early years, which then they have a sudden spike at around 2022, return to normal levels after spike. So lastly, for our data visualization for the percent change on the EDA, on the left we have the code of the line plot for the percent change, which has the date and change percentage. So when analyzing the following data and graphs, the percent change plot displays the daily percentage change in Bitcoin price from 2010 to 2024. Most of the fluctuations remain within a range of approximately -50% to +50%, showing regular volatility typical in a crypto market. However, there is a very sharp spike at around 2013 and 2014. So this plot highlights Bitcoin's volatile nature, especially in its early days, and calls for attention to potential data inconsistencies around the 2014 spike.
So our goal is to predict Bitcoin prices using regression models. Here is the data characteristics for our data. And for the data cleaning, we have potential issues, which are price, open, high, low, need to be converted to numeric types. A volume requires conversion to numeric after removing K and M suffixes. Why regression? It is because regression models are suitable for predicting price, which is a continuous variable based on other factors. And the initial exploration confirms that there are numerical variables that can be used as predictors. So here we are understanding linear regression, which is a fundamental statistical model that examines the linear relationship between dependent variables and one or more independent variables. Goal here is to find the best fitting straight line that minimizes the distance between the observed data points and the line. Here is our linear regression model and its result. So we can conclude that linear regression is easy to understand and explain. This graph shows a single straight line attempting to model the Bitcoin price, which generally the line slopes upwards, which indicates a long-term upward trend in Bitcoin prices. And this linear model would likely yield a low R-square value and high error metrics, indicating that it is not a good predictor for Bitcoin price over this period, since it oversimplifies the complex dynamics of cryptocurrency market. So for random forest, it builds multiple decision trees during training and outputs the mean prediction of individual trees. It's known for its high accuracy and ability to handle nonlinear relationships and interaction between features. Here we aim to predict a continuous output variable with high accuracy and robustness by reducing overfitting and improving generalization through ensemble learning. Here is the model and also the results. With a result of R square of 0.68 and RMSE of 144.59, the random forest model performs reasonably well given the unpredictable nature of Bitcoin prices. The model explains 68% of the variance in the actual Bitcoin prices. This is a moderate score, which is not perfect but decent. The predicted price, which is the orange line, tracks the actual price, which is the blue line, fairly closely, especially from sample 10 and onwards. The prediction improves as the price stabilizes. For the K nearest neighbors regression model, it is a non-parametric instant-based machine learning algorithm that is based for predicting continuous values. So KNN is not inherently suited for time-dependent patterns. It treats data as static and independent, which doesn't work well for financial time series like Bitcoin prices. Here is the model and also the results. We can conclude that a negative r square, which is from their result, implies that the model performs worse than a horizontal mean line. It fails to explain any meaningful variance in the data. And the predicted price, which is the orange line, is mostly flat and fails to follow the blue line, which is the actual price. The model shows sharp artificial drops, likely due to errant neighbor selections, leading to spikes in error.
Okay, previously we have go through all of the machine learning models that are used in this context. And now we will try to compare the three and decide on which are the best for this model. So the machine learning models will be measured with mean average error, which will measures how far off the predictions are on average, and then the root mean square error, which will shows weighted errors of the predictions, and then R square score, which is the coefficient of determination that will measure the proportion of the variance. And the smaller the MAE, the better the result will be. So as the RMSE, the smaller it is, the better it is. However, for the R square, the bigger it is, the better the result will be. And now we will go to the performance comparison. In the ML models, it is seen that in the MAE, linear regression have the smallest value compared to the other three, and then same goes for the RMSE, which have the smallest value at 12.37 compared to the other two. However, on the R square score, linear regression has a perfect score of 1 compared to the other who has 0.68 and even a minus score on KNN. Thereby, we can conclude that linear regression outperformed both random forest and k-nearest neighbor on this context. So it is the best suited model for predicting Bitcoin price trend in this data set. And that will be all from our presentation. Thank you for the attention.